Geometric sequences. It's a sequence that have a common ratio instead of a common difference. And what's a common ratio? Suppose I take two consecutive terms in the sequence and I divide them. I take term 2 and I divide them by term 1. Well, I would get that common ratio. Or if I took term 6 divided by term 5, well, I'd get that common ratio. And if I want to write it algebraically, if I took any term and divided it by the previous term, I would get that common ratio. Okay, so let's use our knowledge here. We'll start kind of easy here, finding the common ratio and the next terms. So suppose I give a geometric sequence. It's going up in a timesy kind of way. Say I've got 1, 4, 16, 64, and I want to find the next two terms of that sequence. This is an easy one because I can see what it's going up by. But let's still get in the habit of calculating that common ratio. The common ratio is term 2 divided by term 1, or term 3 divided by term 2. It doesn't matter. Whoops, 16 divided by 4. Either way, my common ratio is 4. And what that means is each step along the way it's going up by times 4. And so I get term 5 would be 256. Term 6, I take that, multiply it by 4, and geometric sequences can get really big really quick. Okay? So we'll see that again. Geometric sequences always go up by a times number, always go up, not up. They always have a common ratio, even if they're getting smaller. Now this is getting smaller, so what that means, my common ratio is not going to be negative, so to speak. But if you can't tell by looking at it, just use that rule of taking term 2 and dividing by term 1, or term 3 divided by term 2. So if I say 81 divided by 243, I'll get my common ratio. That checks. My common ratio is 1/3. Fractions are better than decimals. Decimals might have, let's not use that 0.3 recurring thing. We don't want to use that. We'll keep it a fraction. Better. So that means it's going up by times 1/3, times 1/3, and times 1/3 each time. So 27 times a third is 9. 9 times a third. Okay, let's try this one. Can you find the common ratio by looking at it? Probably not. Divide two consecutive terms. Let's try terms 3 and term 2. Okay, 9/6 is 3/2. That's my common ratio. I guess we could write 1.5 because 1.5 is a not a recurring decimal. It's a terminating decimal, so 1.5 is okay. So then, okay, we're going up by a times 1.5 way each term. Okay, going up by times 1.5. This guy gives me 20.25. And then 20.25 times 1.5 gives me 30.375. Okay, that's great. Let's move on. So, moving on, let's do finding some term when we know two consecutive terms of that geometric sequence. So, for example, if I say in a geometric sequence, so what does that say? 7th term is 240. The next term is 60. Find the 10th term. You go, okay, well, what'll help is to find the common ratio, because that's what it's going up by each time. I say up, but it doesn't always have to be increasing. So I probably shouldn't say up. Okay, common ratio is going to be, well, 8th term divided by the 7th term. That's 60 divided by 240. So my common ratio looks like it's going to be 1/4, or 0.25. 0.25 is okay, because that's a terminating decimal. I'm going to leave it like that. If I know that's the common ratio, and I want to find the 10th term, and I know that's the 8th term, well, it's going to go 60, what? It's going to go times 0.25 times 0.25 times 0.25 times 0.25, or I can just say, hey, this is going to be that 8th term times 0.25 squared. And that's what T10 will equal. Okay, so if we kind of think of it as a sequence, starting at the 8th term, going up 2 more terms, I can work at it like this. 60 times 0.25 squared. Because squared means multiplying 0.25 twice. Okay, 3.75 would be the 10th term. Okay, suppose this one. I'd say 5th term is 48, 4th term is 64, so obviously my sequence of terms are getting smaller. Find the 12th term. Alright, so first up, let's find the common ratio. It's going to be term 5 divided by term 4, not the other way around. 48 over 64. If it gives me a clean decimal, I'll use it. I'll leave it at 0.75 for the common ratio. Okay, so once we determine that, I say, well, the value of the 12th term, well, what's the most recent term I'm given? I'm given the 5th term, which is 48, okay, and I'm going to say, how many steps does it take to get to that 12th term? And that's what my exponent will be. So 0.75, so what I'm saying is, the 5th term is 48, 6th term, 7th, 8th, 9th, 10th, 11th, 12th. There's that 12th term right there, and here is the 5th term. So how many steps is that going to take to get? We can count, or we can subtract. It's going to take 1, 2, 3, 4, 5, 6, 7 steps to get to that 12th term, which is why that is raised to the 7th power. I don't know, does that kind of make sense? We'll probably get a big decimal here that'll need rounding. So we've got some rounding here, of course. That 12th term is going to be a lot smaller than the 5th term, and we'll just say 6.41 to 2 decimal places for that one. Okay, so this exponent is basically telling you how many steps is it going to take from the most recent term to the term that you want. Right? And we can find that out by just subtracting the term numbers as well. 12 minus 5. That's it for the notes for now. Next time, we'll continue on these. Okay?